Hi, and thanks for joining us for another BigCommerce 360 Summit. I'm Joel Sanders on behalf of Aligent Consulting. Now, you may have seen our talk earlier this year at the Crystal Ball edition, where we discussed headless commerce. Today, we'd like to give you some additional perspective and some technical insights into this with our topic of composable commerce, microservices creating major advantages. First, I'd like to introduce Aligent for those who don't know us yet. Aligent Consulting has been architecting and delivering e-commerce solutions for over 12 years now. These solutions have included B2B, B2C, and hybrid models for our clients. And in fact, our oldest client is both a B2B and B2C based business because long-term relationships are extremely important to us here. We're a highly collaborative agency with a full in-house team, and one of our favorite things is a whiteboard. Aligent is made up of a team of over 70 e-commerce experts, and we span everything from consultancy, UI, UX, through to technical architects and DevOps. We've been known to be pioneering composable commerce and microservices for several years now. And in fact, we've developed and implemented our own progressive web app, which we call TakeFlight. Our culture is extremely important to us, and at the heart of it, these are all the things we stand for. But most importantly for today, we're going to focus on delivering business value and advancing our craft and the community we belong to. So first of all, I'd like to introduce the people that are in today's session with me. I'm Joel. I'm Aligent's Sales and Marketing Manager, and I've been privileged to lead the delivery of several of Aligent's progressive web app projects. However, more importantly to you, I'm joined today by Luke and Torbs, who will be giving you the technical insight. Luke is one of our principal front-end software engineers who has been the technical lead on a number of our most complicated multi-integration point architecture projects. And he's currently spearheading Aligent's PWA and React advancements. Torbs is one of our back-end software engineers and part of the team leading our development and advances in microservices and integrations. So now you know who you'll be talking to. Let's jump in. On composable commerce, Gartner reports that by 2023, organizations that have adopted a composable approach will outpace the competition by 80% in the speed of new feature development. However, that doesn't make it right for everyone. The rigidity and set nature of the more traditional monolithic structure, which you see on the left, may actually suit your business model better. And then, if not, composable commerce adoption can also be via a PBC or packaged business capabilities, or via separate microservices approach. If you are considering the composable approach, and we're big advocates of it, so I hope you are, your strategy should be, first of all, reviewing the services you're looking at utilizing and whether they are, first of all, suitable for a Mac architecture, whether they have documented APIs and suit the integration framework, and finally, have a good support and a clear roadmap of development. So, if you are looking at a composable commerce model with microservices, what gives it the potential to be $1 million move? First of all, it is recognized as a new modern architecture, if not the new modern architecture when it comes to e-commerce. Secondly, if it's done right, it has been proven to be highly performant. And if you want some stats, feel free to get in contact with us after. We can show you. Its structure is based on flexibility, so you can adapt to customer demand and also adopt best-in-breed services as needed. And finally, it has high potential to reduce ongoing total cost of ownership with its ability to swap in and out components instead of falling back to a major upgrade or on even constant replatforming model. So now we've set the scene, let's dive into how microservices work on a technical level. Luke, I'll hand over to you if you could talk us through the front-end considerations for a microservices architecture. Thanks.
Thanks, Joe. What I would like to talk about today are some considerations that front-end developers need to be aware of when working with a backend that is built using microservices. Later on, Torbs will talk about how a backend that is made up of microservices will actually benefit our applications. But for now, we're going to focus on the front-end developer's role in making use of the architecture. So what exactly are we going to cover from a front-end development point of view? Well, we're going to talk about the layer that joins the front end to the backend, the communications API layer. And as we can see from the title on this slide, we're using GraphQL. While this talk isn't on the specifics of GraphQL itself, we should set some context so we understand the technique that we'll demo and discuss in a few slides' time. Firstly, what is GraphQL? GraphQL is a query language for APIs. It allows us to fetch only the data we need, which means no more over or under fetching as with other API communication methods. It is strongly typed, which makes it great for developers as it makes data discovery much easier. It's also a lot more, but we don't have to get into it at this point. What does GraphQL replace? Well, REST API calls, an example of which we can see in the slides now. Why do we want to use GraphQL? We're aware that not everyone who will watch this presentation is technical in nature, and as such, we worked hard on coming up with an approachable analogy that will hopefully help to better understand the differences between the API methods and why GraphQL might be considered a more robust solution. Here we go. Overfetching, as with typical REST APIs, is like going to a restaurant and having the chef cook everything on the menu. They bring out all of the dishes, and then you select the dish you wish to eat. The rest is discarded. GraphQL is like going to a restaurant, looking at the menu, requesting just the dish you want, and then the chef cooking and delivering only that dish. But what does that analogy have to do with APIs? Well, we can request only the data we need for any given view. For example, in the context of a category page, we might only need a product name, image, and price for the product card. So our query will only contain those three properties. When we move to the product page context, where the user is looking for more information about a particular product, that's when we can request that extra information, like description, gallery items, product attributes, etc. What effect does this have on the end user browsing our application? To get a sense of some actual data that represents the difference between the different approaches, I loaded up the Star Wars API, which is a public API that is open for anyone to make use of. What I wanted to understand was the difference in size of response between a REST API call and a GraphQL query. Speed of response certainly would have also been a factor, but because these API examples are hosted separately on separate hardware, it wouldn't have been a fair comparison. So I'm sticking to the one data point that would be consistent: response size. In order to get the names of all the people that were involved with the franchise, using REST, we send a simple request to the endpoint, as we can see here. This results in a response that is 5.8 kilobytes in size. To get the same information using GraphQL, we fashion a query that looks like this, requesting the name property of the people type. This results in a response that is only 2 kilobytes in size. This difference is due to GraphQL returning only the names of the people in the franchise, whereas the REST API call returns names as well as all the other information associated with each person. Let's have a look at a visual representation of this difference. Here we can see the response that GraphQL gets compared to the response that REST gets. As we're not able to filter the data that we get back from the REST API call, we get everything. There is clearly a lot more data returned from the REST call than the GraphQL call, which directly translates to the bandwidth required from a user's device to get this API response. Now that we've talked about how great GraphQL can be, let's have a look at some situations where it could allow us to negatively impact the performance of our app. And that's where we'll start to tie in with some microservices concepts. GraphQL still needs to be used with care and consideration. For example, it's not possible to optimize queries. With REST APIs, the backend controls exactly the data that is available within a request, which means the backend can optimize the database interactions or further API calls in order to meet the predefined data structure. As GraphQL allows the front end to request any property, it's very easy to get into a situation where complex data joins are required within the database to get a value to satisfy the query properties. This leads us to a single property in a query could make the network request take exponentially longer. Not only could complex joins be introduced by a few requested GraphQL properties, so too could external API calls from our backend server. We're going to use stock levels as an example. As stock data is changing very often, it makes sense to use a third-party service that can manage just those values. Torbs will get into the details of that shortly, but suffice to say, in our example, as soon as the front end requests stock levels for a product, the backend will need to request that data using another API call to a third-party service, and then enrich our product data from the database with the stock level data from the third party, finally returning all of that data to the front end to be rendered. This third-party API call will have a visible effect on the performance of the application, as nothing can be rendered until all data is sent to the front end. Stock level information is certainly useful and could be critical information to an application that will only allow add to cart if a product is in stock. But do we need it immediately? Well, if the application needs to know if a product is in stock before allowing it to be added to cart, the answer is probably yes. But even then, it's very likely that the user will browse a product page for at least a short amount of time before deciding they wish to purchase the product. We can dramatically improve the perceived performance of our application by splitting up our GraphQL query. I know what you're thinking. Didn't we cover earlier that one of the main benefits of GraphQL is that we can save on network bandwidth by requesting all data in a single query? Yep, absolutely we did, but not if it's affecting the user experience of our application. But how do we know where to split? If only looking from the front end and short of removing each property one by one until the request is considerably quicker, it's probably going to be quite difficult to identify the property that is causing the slowness. This is where it will be beneficial to chat with one of the backend devs on the project, who will be able to help us identify a particularly complex property that, if requested, would likely slow down response times. And now that we have data coming in at different times, how do we handle the rendering of that data to provide a seamless experience for our users? The answer to this is completely contextual to the application being developed and how it would like to handle that situation. In the demo that we're just about to jump into, we've got a simple loading animation as a placeholder for the content that is about to come. So I've done a lot of talking about this issue, but the best way to really understand it is to see it in action, both before and after. In this demo, we have a product description page with all of the data points that we'd want to see for a product: name, price, attributes, as well as the stock available. For context, this is Takefly, an e-commerce PWA that we've created here at Aligent. Watch what happens if I refresh the page. We can see the loader before the whole product data renders. This issue might not be as obvious, as it's somewhat obfuscated by the full page refresh. So let me trigger an internal refresh, which is much more akin to what our users will see when navigating to our product description page, for example, from a category page. Now that the header isn't also re-rendering, we can see just how long it takes for the product page to render. This gives users a feeling of the app being sluggish. Now, if I go into the code and simply remove the stock level property from the initial product query and instead move it out to its own query, watch what happens. First, the browser is going to reload using a hot refresh because I've changed the code. So again, to really see the difference, let me trigger an internal refresh. We can see that the product page renders much faster, and the stock available property only renders when its data is returned from its own API request. Let me trigger that again. Let's watch this stock available here. We can see that there is a loading animation as a placeholder, indicating to our users that there is data coming. Some final thoughts. Just because we can doesn't mean we should. Consider complexity that might be introduced in the backend when requesting properties over GraphQL. If in doubt, collaborate with a backend developer to understand which properties could result in slow response times and move them to a separate request. And with that, let me hand over to Torbs.
Thank you. Hi, my name is Torbjörn, and I'm here to talk about the backend perspective on using a microservice architecture. So we've talked about using GraphQL to only request the data that we want at any given time. You can think of GraphQL as sort of a gateway to the rest of your data sources. You might have a front end requesting from GraphQL and the back end, and GraphQL can compose multiple sources. In fact, it does this pretty naturally. It's one of its strengths. So GraphQL might be able to go and fetch from your internal catalog data store in the backend, and it might want to go and fetch data from an external provider as well when you request that. The resolver will determine, based on your query, which external sources, if any, it should go and fetch from. Why use a microservice in this case instead of an internal service or just going direct to an external provider from your resolver? One of the big reasons is to reduce the coupling between our components. This means that we can deploy changes independently of each other. So if we have to make a change in our microservice to the way that stock lookups are done, we can do that without redeploying the entire application. It also means that we can insulate the rest of our application from changes in the external system by providing a stable data contract. So if something changes in the way that we have to handle the data coming from our external provider, or we want to plug in a new external provider for some reason, the rest of the app doesn't have to care about that as long as we are returning the same data shape from our microservice. A microservice also allows us to encapsulate any complexity involved in dealing with that external data source. That might be data transformation, maybe the system you use for keeping your stock levels up to date returns data in a form that's not the way you want it for your front end. Maybe it has a different operation paradigm. It might be a just-in-time service, or it might be a regular update service. And your microservice is where you can handle all of that complexity without the rest of the back end, GraphQL, or the front end needing to care about it. Basically, the microservice acts as an adapter for plugging in the services of choice, the ones that you want to use, not the ones that you're tied into because of your choice of platform. Another great improvement from using a microservice is increased observability. This is allowing you to test and monitor the microservice independently of the rest of the system very easily. This is particularly useful for systems that have an inherently high level of complexity or are mission critical. In this diagram, you can see an example of using a step function microservice to take a system that was previously quite opaque and would often fail without really allowing us to find out why it was failing, and breaking it out into a large number of steps, each of which tells us which data is going in and out and lets us rapidly pinpoint what the error in an execution might have been. There are a number of challenges that need to be using a microservice as well that you need to be cognizant of when choosing this architecture. The first is there's an increased communication time almost unavoidably, usually at least one more network request than you would otherwise make. You have to talk to the microservice and get the response back from it. This can be mitigated by good design, only requesting data from the microservice when you really need it, only requesting new data through caching strategies when you really need it. Cost management is another big one. You are going to be involved generally in using another platform, which will have its own pricing systems. Usually the pricing of microservices is negligible or manageable, but it is vital to understand and monitor this, and costs can get out of control if the architecture is not designed properly. And finally, there's a level of knowledge management that your organization needs to take into account. New platforms and technologies are involved here. You might have to hire or retrain staff, and there's an increasing fragmentation which is by design with a microservice, but you want to make sure that you avoid an explosion of microservices and only utilize them where they can be kept separate and independent so that they can deliver their benefits. Avoid building a distributed monolith, which gives you the worst of both worlds.
Thanks, Luke and Torbs, for those insights. We here at Aligent hope the technical insights into how the composable architecture works and considerations you should be making in choosing your architecture have been useful today. While we've focused on stock levels from a microservices perspective, it's important to note that microservices can be used for a large range of functionality in your e-commerce architecture, ranging from find in store, search merchandising, loyalty, payment options, and more. As a $1 million move, composable commerce has the potential to provide significant business value through an agile, flexible architecture, ensuring you can respond to customer demand with new and emerging customer services as they demand it. So if you're interested in finding out more, please do feel free to get in touch. Thanks again to BigCommerce for putting together this summit. We hope you enjoy the great topics covered by our fellow speakers and have got something out of our talk today. Thanks again.